Hello guys, welcome back to our channel. In today's video we will be discussing about a new chapter, carbon and its compounds from grade 10. It is chapter number 4 in science textbook of grade 10. And in this video we will start this topic, and in this video we are going to discuss about properties of carbon. That means what is the basic information that we need, to understand this chapter. And the next one we are going to understand is versatile nature. And then we'll go to functional groups. F means functional and G means group. I just wrote in a short form functional groups. And then the last one, and this is the important one, that is nomenclature. All these three are important to understand this nomenclature, which is an important topic. In this video we are going to learn about those those four topics only, and I'll give you some sums to solve on nomenclature. First we will see how carbon is available. In Earth's crust means the top layer of the Earth, it is available in the form of carbonates and minerals and etc. How much? It is 0.02%. And in Earth's atmosphere, it is available in the form of CO2, and that is 0.03%. This is how we find carbon. We never find carbon individually, but we can find carbon in the forms of CO2 and carbonates and minerals also. Now we will know about the properties of carbon. That is the information that we need to understand this chapter. First thing of carbon is, let's start with atomic number. We have many things to discuss about carbon, but now we'll start with atomic number. What is the atomic number of carbon? Atomic number of carbon is 6. From this point we are going to tell another point, which is its valency. Can anybody of you tell valency? You can tell it. Of course the valency will be 4, because K shell will take 2 electrons, L shell will take 4 electrons, and to gain electronic configuration, carbon need to lose or gain 4 electrons. So its valency will be 4. And this carbon is called a versatile element. It is called a versatile element because everything we use in your daily life definitely is made of carbon. And let us see what will happen. What will it do to gain electronic configuration? Maybe some of you may be thinking that it will gain or lose 4 electrons, but it is not that situation. It will neither lose 4 electrons nor gain 4 electrons. So we will see what happens if 4 electrons are gained. This means electrons gained, and this is if first point 4 electrons are gained. So we know that the atomic number of carbon is 6. That means neutrons are 6, protons are 6, electrons are 6. But as 4 electrons are gained, the number of electrons will become 10, right? So it is not easy for 6 protons to handle 10 electrons. That is why carbon cannot gain 4 electrons to gain electronic configuration. I repeat, carbon cannot gain 4 electrons because it is difficult for 6 protons to handle 10 electrons. Okay? Hard for protons. Okay, I'll write in words itself. Protons to handle 10 electrons. I'm sorry, here it's 6. It's hard for 6 protons to handle 10 electrons. And for the next one, the next point is 4 electrons are lost. It can't even lose 4 electrons because removing electrons needs a very high amount of energy. Removing electrons need very high amount of energy. This is why it can't even gain or lose 4 electrons. Many of you may be thinking that if it can't gain or lose electrons, how it is going to gain electronic configuration state? If you write whatever you understand, I'll continue with the class and then you can know how it can gain electronic configuration. So carbon hence overcomes this difficulty by sharing its electrons. As it can neither lose or nor gain, so it is overcoming this difficulty by sharing of electrons. This sharing of electrons may be done with carbon or other elements also. This can be done with carbon or other elements also. This carbon valency has 4. So carbon's valency is called tetravalency, and carbon is called tetravalent atom. And the bonds formed by this sharing of electrons, these sharing of electrons are called covalent bonds. I repeat, the bonds formed by sharing of electrons are called covalent bonds. Now the next step we do is comparison between covalent bonds and ionic bonds. This is also very important in the given topics. This side we will write covalent bonds and this side we will write about ionic bonds. Simple, and it is very easy to understand. Okay, in covalent bonds, the melting point BMP and BP boiling points are less, and in ionic bonds the melting point and boiling point are very high. I hope you understand. And ionic bonds are strong compared to covalent bonds. Simply we can write them as weak. And covalent bonds have intramolecular forces, but ionic bonds have intermolecular forces. Intra means between molecules, but inter means inside the molecules. These are the main 3 differences that you need to know about ionic bonds and covalent bonds. With this we completed the first objective of this video, that is properties of carbon, and then we are going to learn about what is that? It is versatile nature. versatile nature of carbon. Carbon is versatile in nature because of three reasons. The main three reasons are catenation. Catenation. It is the unique property of self-linkage of carbon atoms by means of covalent bonds to form straight chains or branched chains or different rings or different sizes. Simply we can tell it as ability to form continuous chains. Simply we can tell it as ability to form continuous chains. Like example C, 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 C and so on, and here also so on. This is called catenation. This is the ability of carbon. And the next one we are going to discuss is tetracovalency. Tetracovalency. As carbons are very small in size and its valency is 4. It has 4 valence electrons, because of which it can form very strong bonds with other carbon atoms or hydrogen or oxygen or nitrogen also. For example, carbons bonded with hydrogen are called as hydrocarbons. C are small, carbons are small, comma, 4 valence electrons. Due to this, what is happening is strong bonds with H, O, N, S, H hydrogen, oxygen, nitrogen, sulfur. And if carbon is bonded with H, if this bond is created with C and H, it is called as hydrocarbon. When C is bonded with H, we call them as hydrocarbons. And the last one, because under the versatile nature of carbon, is its multiple bond formation. Multiple bond formation. Okay, multiple bond formation. Because of the same reason, as carbon atoms are small, it enables carbon to form multiple bonds such as double bonds and triple bonds with other elements as well as its own atoms. Because of the same reason, C are small, it forms double and triple bonds with other atoms. With this, we can end the second subtopic in this video, which is the second important topic in this video, that is versatile nature of carbon. These three are very important under versatile nature of carbon. We may get 2 to 3 mark questions based on this. I am going to erase this all. And from here, you need to listen very carefully, because functional groups are also linked with, those are the main things that are linked with nomenclature. Nomenclature, we may get 2 to 3 mark questions or 4 to 5 mark questions also. We may get them in the MCQs also. They are very important. Nomenclature is the most important topic in this lesson. Let us start with the third important topic of this video, that is functional groups. First of all, going into deep, we have to know the definition of these functional groups. So what do we mean by functional groups? Functional groups are a set of atoms. Okay, functional groups are a set of atoms or a group of atoms which when present in a compound gives a special function to them. An atom or a group of atoms which when present in a compound gives specific properties. An atom or group gives specific properties when present in a compound. An atom or a group gives an atom or a group which gives specific properties when present in a compound. That is defined as functional groups. And according for our lesson, we have four functional groups, and those are alcohol, aldehyde, carboxylic acid, and ketone. We will start with that. First, functional group, and then we have here formula, and then suffix. We can just keep in mind about the suffix. I'll explain you very deep about that suffix in the later video, in the later topic, because suffix comes under nomenclature, and whenever we add functional groups, suffix will be different. So we'll just keep this aside and you just note it down. First functional group we are going to start is alcohols. Its formula will be single bond OH, and this will come at end of the chain. Okay, and its suffix will be O and L. I hope you understand. And the next one we are going to discuss is aldehyde. There are no properties, we have to just remember the functional group name, formula, and suffix. Very easy. Aldehyde is single bond C, double bond with O, and single bond with H. Okay. For your clarity, I'll draw in a very simple manner than this, like this. In chains, while drawing nomenclature, we can get this. And its suffix is, I hope you will be thinking that is DE, but it's not DE, it is AL. This AL. And the next one we have is ketone. It's just R C R double bond O. Maybe many of you may be wondering what is the meaning of R. R means continuous chains. Remember, R means continuous. R means continuous chains. And I forgot to tell, aldehyde functional group also comes at the end, but ketone is the odd one out for all the four, because ketone comes in between of the chain. It comes in between of the chain. The chain will be extended in this direction, this direction, and O will be coming double bonded with carbon. One carbon will be double bonded with O, which is called ketone. That functional group is called ketone. And this two lines represent double bond and single line represent single bond. This will be very useful while the time of nomenclature and the further explanation of this chapter. Never forget about the double bonds and single bonds and triple bonds. Okay? What do you think about its suffix? It's O-N-E. Own. It's not one, it's own. And the last one is carboxylic acid, and it will be R. C OH, single bonded with OH and double bonded with O. And there's one difference between aldehyde and carboxylic acid. Never get confused. And before that, this also comes at the end. The difference between the aldehyde and carboxylic acid is here double bond O, that is okay. But here single bond OH, but here it is only H. And the suffix of carboxylic acid will be oic acid. Okay, these are the functional groups, and we have halogens also. I'll explain you what are halogens. Let me erase this. In functional groups, anywhere did you see the inclusion of any other elements such as N, Cl or Br or something else? Did you ever see inclusion of these elements in functional groups that we discussed before? Yeah, no. The answer is no. Functional groups which we discussed before only contain oxygen or hydrogen, and it may be oxygen and hydrogen both also, but functional groups does not contain this. But halogens, both are same, but halogens are the functional groups which are made of other elements. So halogens will contain these. So halogens examples will be N, Cl, Br, and you have many etc. In this chapter we will be only studying about Cl and Br, and suffix will be chloro, bromo. These can come at any part of carbon chain. It can come at the middle of the carbon chain or the end of the carbon chain. Okay. Now the next important topic is alkenes, alkynes and alkanes. We have very much